Okay, so far we've just been simplifying rational expressions. And now we're going to talk about rational equations. What's the difference between an equation and an expression? What's an equation have? An equal sign, right. And so the first ones we're going to do are when they are proportions. Does anybody remember what a proportion is? When they balance each other out, yeah, they're proportional. But what's that look like in a math problem? Anybody remember? It's just when you have a fraction equal to a fraction, okay? So in other words, there is no plus or minus sign between the fractions. All we have is this equal sign right here, right? Okay. So when that's the case, if all I have is an equal sign between my two fractions, I can use cross products, which we have done before in the past. So if I cross multiply 2 times x minus 3, and I want to write it in parentheses so I remember to distribute it. If I distribute by 2, I get 2x minus 6, and that equals 3x. So if I subtract 2x from both sides, I get that x is equal to negative 6. So we want to double check that that works, because every now and then we will have problems that don't work when we plug them back in. So we want to make sure this works. So I'm going to check my answer by plugging it back in. So 3 over negative 6 minus 3 equals 2 over negative 6. So here I get negative 3 over 9 equals negative 2 over 6. If I reduce both of them, they both equal negative 1/3, so I know I did it right. And then x equal to negative 6 is the correct answer. Okay? Any questions? Alrighty, so here's one for you guys to try on your whiteboards. Okay, so you should get x equals 1. And then if I go back and check it and plug it in, 4 over 1 plus 1 equals 2 over 1. I get 4 over 2 equals 2 over 1, which is true because they both reduce to 2. So that means I did it correctly. Okay. All right, so are you guys pretty comfortable with cross products because we did them in the past? Just make sure you remember to distribute. That's the only part that's tricky, okay? Alrighty, so now we're going to do them when they do have a plus or a minus sign. We're going to multiply by the least common denominator to do fraction besting. Okay, so looking at the first example, we've got 1 over x plus 3 over 2x equals 2 over x plus 1. So if we think about how we get our greatest common, not our greatest common factor, our least common multiple or least common denominator, we have to have something that all of those will divide into. So eventually you guys will probably be comfortable where you can do this in your head, but if you break it down into prime factorization, then you can kind of see where they overlap. In this case, I need to have a 2, an x, and an x plus 1. So my LCD is 2x times x plus 1. Because all of those, x will go into that, 2x will go into that, and x plus 1 will go into it. Okay? All right, so now what I'm going to do, first of all, I'm going to go ahead and erase this to make myself some room. Is that okay? If I erase the little part with the LCD? Okay. All right, so first thing I'm going to do, I'm going to rewrite the problem, and I'm going to give myself some room between each of the terms. And then on top, I'm just going to multiply everything on top by my lowest common denominator. So times 2x times x plus 1 times 2x times x plus 1 and times 2x times x plus 1. And then I go through and reduce everything, and my fractions are gone. So on the first one, I can cross out an x. On the second term, I can cross out 2x, and on the right side, I can cross out the x plus 1. All right, so now I'm left with 2 times x plus 1 plus 3 times x plus 1 equals 2 times 2x. So distributing, I get 2x plus 2 plus 3x plus 3 is equal to 4x. Combining my like terms, the 2x and the 3x, I get 5x. 2 and 3, I get 5. And so I'm going to go ahead and subtract the 4x and subtract 5. So I get that x is equal to negative 1. No. Yes. No. Negative 5. I don't know why I said that. Okay. X is equal to negative 5. You guys agree with me? Alright. Are you guys just as sleepy as I am? That's what it sounds like out there. Okay, let me check the answer really quickly. 1 over negative 5 plus 3 over 2 times negative 5 equals 2 over negative 5 plus 1. Alright, so then I have negative 1/5 minus 3 over 10 equals negative 2 over 4. I can reduce the 2 over 4 to negative 1/2. When I get a common denominator, I end up with negative 5 over 10. So does negative 5 over 10 equal negative 1/2? Yes, they're equal. It's just not reduced. So, all right. So I know I did it right. Okay. So I've got one for you guys to try. What I want you to do first is just tell me what you think the LCD is. Show me that before you do anything else. Okay, so the LCD was a times a plus 1. So now what you're going to do is you're going to multiply all of your terms on top by that LCD. If you want to put a 1 under it, if that helps you see it, that's fine. You can do it like that if you need to. Yeah. Okay, and that's an A. Okay, so at that point you just reduce everything and solve it. Okay, so you should have ended up with A equals negative 4. After your fraction busting, you have 2A plus A equals 4 times the quantity A plus 1. So when you distribute and then subtract, you end up getting A equals negative 4. If I go back and check it, 2 over negative 4 plus 1 plus 1 over negative 4 plus 1 equals 4 over negative 4. So here I have 2 over negative 3 plus 1 over negative 3 equals 4 over negative 4. You end up with negative 1 equals negative 1, so you know you did it right. All right, so now let's take a look at this example. We've got 12 over x squared equals 1 over x plus 1. So what do you guys think the lowest common denominator is going to be? Can I have just an x? So if I have an x on top and an x squared on the bottom, is everything going to go away on the bottom? No. So what's my LCD going to have to be? X squared, okay? Because if I have an x on the top and an x squared on the bottom, oops, I did it upside down. Yeah, no, I did that right. If I have an x squared on the top and an x on the bottom, the x is going to cancel out and the fraction is going to go away. So, yeah. All right. All right, so that's what I'm going to multiply everything times. I'm going to have 12 over x squared, and I'm going to multiply that times x squared equals 1 over x, again, times x squared, plus 1 times x squared. So here my x squareds cancel out. Here just an x cancels out. And nothing cancels out on the last one. So now I've got 12 is equal to x plus x squared. Okay, whenever it's a quadratic, if you have an x squared, that means you have to make it equal 0, and then you have to factor it. Or if it doesn't factor, use the quadratic formula. But all of these are going to factor, I'm pretty sure. Okay, so what do I have to do to make it equal 0? I need to subtract the 12, right? So I get x squared plus x minus 12 is equal to 0. And then we factor it. That's a pretty easy one. Any volunteers? So that means that x has to either equal -4 or +3. And because of time, I'm not going to plug it in right now, but if you plugged it in, it would work. All right, I need to show you one more example before we go. So we're not going to have time for that one. All right, let's take a look at this one. Let's see what happens here. Jose, what's my lowest common denominator here? What will 3, 5, and 15 all go into? Dawson? Okay, you got it, Jose. All right, so 15x, right? So I'm going to do 2 times 15x over 3x plus 4 times 15x over 5x equals 6 times 15x over 15x. Going through and canceling out all the x's. And 3 goes into 15 5 times, 5 goes into 15 3 times, and here the 15's cancel out. So I have 2 times 5, which is 10, and 4 times 3, which is 12, equals 6. What happened here? Is that possible? No. So if you ever get one like this where all the variables drop out and you end up with a false statement, then that means there is no solution. I want you to write no solution, or if you prefer to just write the empty set, the null set, you can do that too. Okay? All right, and I think that's about all we have time for today.